Okay, so we are down people today. I know about half the class is at a programming contest or out of town somewhere else or stuck in traffic. So it's y'all, but we've got the stream. People can keep watching and you can comment and stuff on what's happening. Where are we? We've been working on steering behaviors. You've been working on little mini games about steering behaviors. Questions, things you learned by implementing that, things you still didn't get to work in your games that you want to. What were some good things? What were some unfortunate things about trying to make that happen? What went well? Let's talk about that first. What went well?
My pursuit was pretty good.
The pursuit steering function.
Yeah.
Other people. Let's just go around. Dalton.
I don't like the way I have a wander, and I like the way my wander is working.
How did you get it to work?
I gave it a couple parameters so that I could have a little bit more control via magic numbers. So I have like a circle that sits in front of an imaginary circle that sits in front of the object that's wandering, and then an angle within that circle to tell it how much to step off its previous step.
Okay.
And so then it has the ability to...
Because there is the danger in wandering to be jerking back and forth all the time. That can happen if you're just picking a random angle. So by doing it off of that circle, it's always going to be focused just in front of you. Small incremental changes. That's a good idea. Yeah, Luke. What went well?
Well, I had things that would, like, depending on how close the user was, they would either run away from you, or if you were too far, they'd go back to wherever they wanted to be. That worked pretty well.
So you had some kind of choice happening inside them.
It wasn't really a choice. It was like, if you're too close, I'm going to run away from you now. But if you're far away, they're like, okay, I can go back to my spot safely.
Okay.
So that went well.
Okay. And that idea is going to come up probably next week, where we start to say, I have different things I want to do. I'm not just an agent doing one thing. I have different states that I want to be in. How do we transition between those? So we'll talk about formal ways to get that to work. There's simple ways. There's more complicated, abstract ways to put that together. Rebecca.
My arrival went pretty well.
Arrival. So it slowed down when you got close to it?
Mm-hmm.
Nice. Mitchell. What went well?
My arrival, I wrote an arrival as well. I felt like that was going to be difficult, but it wasn't. I was successfully able to get I was successfully able to get the creatures to spawn.
Okay.
And make little babies in the game.
So the instantiation during the gameplay of new objects. Okay, cool. Jack.
I have problems on arrival.
Okay.
Yeah, and heard others' opinions. I try to get some chance.
Okay. Yeah, you've got to take that size and use that to slow you down.
Yeah.
Right? Is that what you did, Rebecca? You said, this is my distance, my size should be scaled, slowed down appropriately depending on how far away I am. Okay, cool. What didn't go well? What did you struggle with? What is still not done in your little mini games?
Some of my implementations of the steering behaviors are like the simpler versions instead of the more complex ones.
Okay.
Like, because it had improvements on those tutorials, and some of those improvements I didn't get to.
Okay. Didn't get as far as you wanted to on putting them together. But was it easy to compose steering behaviors? Mm-hmm. Hoping that thought was carrying through, saying, here's a small script that does one behavior, here's a small script that does another behavior. You could put two scripts on one object, and they would both be adding forces at different times and pushing it in different ways. Thinking about a steering behavior like that will make your game more modular and more composable. Because you could add a script and remove a script and disable things programmatically as you go. We'll think about that later as well. So, what else didn't go well?
I felt like as I added more scripts and therefore more forces to my object, it continuously speeds up. Is there a way to like reset the forces it feels so that I'm not continuously building? I feel like I have like an acceleration more than
We
like
can give it a max.
velocity.
You can give things a maximum. You can think about having them as pieces of a larger weighted script, and then that larger script has a maximum velocity, and you say this steering behavior gives me 30% of what I'm supposed to do. This one gives me 40%, this one gives me 30%, and they sum up to my speed instead of each accumulating speeds above and beyond where I was before. So I think one of the pages in that tutorial said, here you have 4 steering behaviors. Think about how to weight them and put them together inside one big steering behavior. That is the trend that I see when people take this and say, I want to make a library that people can download about steering behaviors. It's small pieces you can compose, but there's all this larger piece around it. Other things, other struggles. Yeah.
I had objects that were colliding into each other, even though they were very far apart. And it had nothing to do with the collision mesh being too big.
Okay. And you're still not sure why?
Yeah.
Okay. We'll have to look at that one. I can't think of that off the top of my head. It's usually the collisions only happen when the collision meshes touch. We'll see. I don't know. Other things. What about the game itself? You were trying to think not just, hey, I'm implementing some small project, but you were thinking about game design principles, maybe, possibly. What about those were easy and hard and interesting to think about? What did you do to try to come up with a goal for your game related to steering behaviors? So that was part of what I was hoping you'd think of as well. Not just, I have swarms moving, but there's some reason, there's some purpose to what's going on. Yeah, right.
I just have 100 ships, and you're trying to kill them while some of them are trying to kill you as well. So if you can kill all the ships, then you win, but that rarely happens because there's so many.
Okay. So having too many things to try to kill, thinking about games need to be easy for people to get into and get into play. That's something that comes up outside of just trying to get some steering behaviors to work that you need to have a consideration for. Did anyone think of a game that was too complicated for them to implement? Good. So that's one of the first things. Make sure you start easy and small. Trying to get you on that idea here instead of saying, I have this 15-level game I want to make about steering behaviors, and I have 3 days to do it. Don't do that when you have this project due. You want to start off small, and hopefully this was an example of you can get something interesting to happen with just a little bit of behavior, expand it, get it to work, make it bigger, make it better along the way. Okay, so what's coming up? We're going to talk now about navigation and pathfinding. Now that we have our objects moving around, forces, making them do things, navigate through the space, we want to do it intelligently and find ways to avoid obstacles and walk through our whole world. So, let's see some algorithms of how we could do that. This is from the Unity documentation. They have a nice system which we'll explore for doing navigation and pathfinding, but we need to know the sort of the theory behind what's going on. How does it fit together? Navigation and pathfinding is a particular type of search. Now, based on your prerequisites for this class, the intro and data structures, you should have some idea of what search is in computer science. What is search? What is the search topic? And where do you hear that word come up? What kind of searches do you know about? Binary search. You try to say, I have a list and I can find things, or I have a binary tree that structures the information. I know where to go left or right based on a small little question that I ask. Good. What other kind of searches do you know? Depth first, breadth first. Yes, you all heard of those. What is the way that they work? And what are you searching in breadth first or depth first search? Usually trees or graphs. It's usually commonly a state space, places you want to go, and as you search, you look through a tree and come up with possible branches of what's going on. Okay, any other types of search? Breadth first, depth first. Let's see how those might work to try to solve the pathfinding problem. We have an agent in our world, and it needs to go to a target. The way we've done that so far is to implement a steering behavior that says, do a bit of math with the vectors. That's where you want to go. Push yourself in that direction. But there might be stuff in your way. There might be other things involved. Let's see how those algorithms of breadth first, depth first search might not be the right way to go. So, here is an example. Oh, I have to reload the page because it lost all my pieces. Breadth first search. We are the green square, and we want to find the red square. We just know there's a red square out there. It's as if we don't know the exact coordinates of our target, but we'll know the target when we see it. That's the idea behind this type of search. So we are at the green square, and we don't want to be moving yet. We want to be sort of exploring the space theoretically around us. Where could I go, and how can I find the best way to get to that red square? So when we run it, there we go. Okay. Much better. So, green square, red square. Let's start a breadth first search. It will slowly explore all the places around us, piece by piece by piece, using what kind of data structure underneath it? A queue, yes. Breadth first search looks at things in a queue. And it says, I'm looking at a square. This one is not what I want. Where else can I go from it? Put those at the end of my list. Take something else off. There's this open and closed list. Things are being taken, put back on. If we do depth first search, we're trying to find things by saying, here's where I am. That's not where I want to go. Let's look at something immediately around me. Let's look at something immediately around me. What are the compromises between breadth first and depth first search? Let's just do a quick review. Why would I use one over the other?
Breadth first is guaranteed to find what you're searching for.
Yes, you are guaranteed to eventually find what you're searching for. What's the negative part of it?
It takes forever.
Forever, yes. And you are having a huge amount of memory kept around as well. So this is the green, the light green is the frontier of where it's looking, and it has to always remember all of these possibilities. If that's not what I want, the size of the queue keeps expanding and expanding and expanding. Depth first search does not keep a huge list of possibilities. It does a stack, puts them together. Well, what's the consequence of depth first search? You're not guaranteed to find out what you're doing. Yes, we don't know if we start doing depth first search to the left that we're ever going to get to where we end up. We might just keep on doing depth first search all the way